Hi everyone. By the end of this video, you will have a clear idea on difference between accuracy and precision in a measurement. Then we will see errors in measurements. There are mainly three types of errors. Absolute error. What is absolute error? Then what is fractional error or relative error? And percentage error. And the last, manipulation of errors in addition and subtraction, and manipulation of errors in multiplications and divisions. Let's see the difference between accuracy and precision. Accuracy tells you how closely your measured values are close to the true value. Let's see an example. My height is 174 centimeter and I made two measurements. One is 174 and the other is 174.004. Which is more accurate? This measurement is more accurate. Why? This measurement is very close to the true height. So this is more accurate. What about this? It is not at all accurate. Why? There is a difference of 0.04 centimeter from the actual value. Precision depends on limit of resolution of a measuring instrument. What do you mean by limit of resolution? Limit of resolution is the least count of the instrument. Limit of resolution or least count depends on the number of decimal places. More the number of decimal points, look at this, 3 decimal points, 3 decimal points, 3 decimal points. More the number of decimal points means more precise. Look at these set of measurements, only 1 decimal point, which is having less precision than the first set of measurements, which means the first set of measurements have a range from 17.001 to 17.003. So close to each other. All the measurements are so close to each other. Look at the second set of measurements, which is between 17.0, 174.0 and 174.3. This is having less precision. Why this set is having less precision? Because the measurements are not very close to each other as this. So precision stands for the closeness of the measurements. So the first set is very close to each other than the second set. So the first set is more precise than the second set. Now let's do some questions. My height is 174 centimeter. We made two measurements. First measurement is 174 and the second measurement is 174.00 centimeter. Which measurement is more precise? This measurement is more precise. Why? That is 3 decimal points. 3 decimal points means that gives you the measurements more in detail. You can see here only 174, but this gives you more in detail. So this is more precise than the other one, but sure, this is not accurate. Why? This is close to the true value. This is nowhere close to the true value. Another question. You have two sets of measurements, same as before, and they wanted which one is more accurate. Accuracy tells you closeness of the measurement. Your measurement is 174. This measurement is very close to 174 with no error. So this is more accurate. What about this? There is an error of 0.04 centimeter. So this is not accurate even though it is precise. Let's do some questions. A student performs an experiment which measures the boiling point of pure water, and we know the boiling point of pure water is 100 Celsius. And the 4 measurements he made are these. Are they so close to the true value? 100 is true value? No, they are not so close. So they are not accurate. So this seems to be okay. They are highly accurate, wrong. Highly accurate, wrong. Let's see whether they are precise or not. All the measurements are very close to each other. 82.1, 82.0, 82.2. Not, they didn't spread a lot like 90, 100, 110. No. So they are very close to each other. So they are very precise also. So the answer is B. Now, another example. Someone made a measurement of the mass. The true value is 10.0 gram. But look at the 4 measurements he made. 9.1, 10.9, 9.5, 10.5, etc. Are they so close to each other? No. They spread over a range of 9.1, the minimum value, to 10.9, the maximum value. So they are not precise at all. Are they accurate? How do you know whether it is accurate or not? You go for the average of all your 4 measurements. And when you find the average of all the 4 measurements, that gives you 10 gram. It is exactly the same as the true value, so it is highly accurate. So the answer is A. Another assertion reasoning type question. It is possible for a set of measurements highly precise, close to each other, but highly inaccurate. That is possible. The previous example, you remember, this is the true value, but you made so many measurements. Are they so close to each other? Yes, they are precise, but those measurements are not accurate. So that is what the assertion says. What is the reason for that? See, there was a consistent difference of almost 18 degree in all your measurements. All your measurements are 18 degree below the true value, which means there is a difference of same amount from the true value, around 18 Celsius, but they are precise. So reason is there is a difference of 18 degree. So reason is also true, and the reason is the correct reasoning for the assertion. So the answer is A. Another assertion reasoning type, decreasing the least count of an instrument. I will show you one instrument has a least count of 0.1 centimeter. Another instrument has a least count of 0.01 centimeter. So decreasing means it increases the number of decimal places, which will increase the precision. True. Let's see the reason. Assertion is true, which means this is wrong. Do you think reason is the correct explanation for that? Yes. Decreasing the least count increases the number of decimal points. Before only 1 decimal point. So assertion is true, reason is also true, and the reason is the correct explanation for the assertion. So answer is A. Let's see some MCQs. The instrumental error can be minimized. Instrumental error means error in measurement due to something wrong with the instrument. How can we minimize that? Use different instruments. And of course, make sure it is more accurate instruments have to be used. So the answer is B. Let's go for the next question. The magnitude of the difference between mean value and each individual value is called absolute error. That is the definition of absolute error. Difference between the mean value and the individual value. We call it as absolute error. Another question. Ratio. Ratio is always relative. Ratio of the absolute error and the true value. Another name, mean value, we call it as relative error. And when you times relative error by 100, you get the percentage error. The measure of accuracy, is it absolute error, relative error, percentage error, or both B and C? I'll give you an example. Look at this. This is first measurement, 100 centimeter plus a 2. This is the absolute error. Second measurement, 10 centimeter plus or minus 2. Both of them have same absolute error, plus or minus 2 each. Now let's see the percentage error in both. 2 divided by 100 to get the percentage times 100, which is 2%. 2 divided by 10 times 100, 20%. Which one has more error? This is having more error. So this is not very accurate. So accuracy can be measured with not the absolute error. Why? Same numbers you have, but when you go for the percentage, and you know the difference between percentage error and relative error times 100 gives you percentage error. So the measure of accuracy is not the absolute error, it is both relative and percentage errors. Let's do a question. The side of an object is measured with an instrument. How much is the length of the side of the object? 4 centimeter, and the least count is 0.01 centimeter, and they wanted the percentage error in measurement. How do we do that? For that, the given stuff, least count is 0.01, which is written as, so the absolute error in measuring y is 0.01. And how much is the true value of y? 4. And what do you want? You want the percentage error. Formula for the percentage error, absolute error divided by the true value times 100, which is 0.1 divided by 4 times 100, 0.25%. We go for another question. The side of a cube is measured as 20. So this is the true value. This is the absolute error. And they wanted the percentage error in the measurement. Absolute error 0.02. True value 20. The percentage error, take the ratio between the two. 0.02 divided by 20 times 100, which will give you 0.1 percentage. That's all. Thank you so much.